All right, we're going to do the problems with the Coulomb's law, right? So the other part is going to be done in class with the how to charge a body. And the formula is given, and it looks similar to the formula for the force of gravitational attraction. But this one can either attract or repel, depending on the signs on the charges. So let's do some of these problems here. And I'm going to keep this formula here. F equals K Q1 Q2 over the distance that separates them squared. A negative charge of -2 times 10 to the -4 exerts an attractive force of 65 newtons on a second charge. So now we know that the other charge has to be positive. What is the magnitude of the second charge? So really you just have to use this formula, and you say 65 is 9 times 10 to the 9th power times 2 e to the -4, or if you want to put -2 here, you have to put a negative here for the force because it's an attractive force, times Q2 over d square, which is 0.05 square. And you would just solve that equation. We'll give you the answers here. That should be 9.03 times 10 to the -8 coulombs, right? For number 2, find the force between a positive charge of 1 microcoulomb. Now, a micro is 10 to the -6 coulomb, right? So this is 1 times 10 to the -6 coulomb. When they are, and a positive charge of 2 microcoulomb when they are 0.03 meters apart. So again, you just use the formula. So 9 e to the 9 1 times 10 to the -6, 2 times 10 to the -6 over 0.03 square, and the answer should be exactly 20 newtons. So just pay attention to when it says micro or nano or milli. Number 3, what is the distance between two spheres, each with a charge of 2.5 10 to the -6? So that's basically 2.5 micro coulombs, right? When the force between them is 0.5 newtons. So we're going to say 0.5 equals 9 times 10 to the 9. Now the charges are the same, so I'm just going to multiply them together, or just square one of them, divided by d square. Now how do you solve this? Well, I can just move the d square here, divide by the force, which is 0.5, and I guess take the radical of this whole thing here. That should be your distance. And the distance should be 33.54 centimeters. So it was 0.3354 meters. Now, net electric force problems, meaning like you have more than 2 charges interacting. Okay. A positive charge of 3 microcoulombs is pulled by 2 negative charge. All right, so let's just do this. So here is the positive 3 microcoulombs, I guess, right? One is -4.5 microcoulombs, and it's to the east. I guess we're going to look at right as east. So one of them is here, so that's the -4.5, and the other is to the west, and it's a little bit closer, right? So this is the -4. This distance here is 0.04 meters. This distance here is 0.06 meters. What is the net force on the positive charge? So we concentrating on just what's happening to the positive 3. So it's being pulled by this 4.5. So I don't know. I guess I can call that F2. It's also being pulled by this -4, which I'll call F1. So the final answer will be the difference of those two. And the one that's bigger in magnitude will win. Now, when you're trying to find F1 and F2, do not consider the sign of the charge. Okay? So just find the magnitude and let the drawing decide whether it's positive or negative. So it's 9 e to the 9 times 3 e to the -6 times 4 e to the -6, positive 4. okay, over 0.04 square. And you do the same thing for F2. So you would do 9, 10 to the 9 times 3, 10 to the negative 6 times 4.5, 10 to the negative 6 over 0.06 square. And those two forces should be the first one should be 67.5 newtons. Okay, that's the magnitude of it. And the other one should be 33.75 newtons. Okay, so it looks like F1 is bigger, so your net force will be to the left, which means it's going to be, I guess, negative, or we can say west. So if you subtract those two, you should get 33.75. That has nothing to do with this 33.75. That's just, this is what I'm writing now is the difference between those two. So 33.75 newtons, right? You can put a negative here, or you can say west, whatever you want to do, or west, if you don't want to write the negative. Okay. Okay, charge 1 is negative 4.5, 10 to the negative 9 Coulomb. 10 to the negative 9 is what we call nano, right? Is located at the origin. Charge 2 is 0.02 below charge 1 and is, okay, so these are in line. Okay, so here's charge 1, so which is negative 4.5 nano, okay. Okay, charge 2 is here, and it's 3 nano, right? Charge 3 is located 0.8, so let me just label this stuff here. So this is 0.02 meters, and this whole thing here is 0.08 meters. Okay, and this is charge 3, and it's 6.5 nano. Okay. What is the net force on charge 1? Well, let's see what's happening here. So this is a positive charge, this is a positive charge. Yep, okay. So it's going to be attracted by charge 2, but it's also going to be attracted by charge 3. So the net force will be pointing down, and it's going to be the sum of those two forces. Okay? Okay, so let's just say F2 is equal, in magnitude, is 9 times 10 to the 9 times 4.5, 10 to the negative 9 times 3, 10 to the negative 9 over the separation distance is 0.02 meters, and you square that. And the answer should be 3.04, 10 to the negative 4 newtons, right? So F3 will be following the same formula. F3 is here, so it's going to be 4.5, 10 to the negative 9, 6.5, 10 to the negative 9 over 0.08 squared. And that should be 4.11, 10 to the negative 5 newtons, right? So the net force will be the sum of those two, and it's going to be pointing down. So if you add them, you get 3.45 e to the negative 4 newtons down. Or if you want to put negative and consider down as negative, that's fine too. Okay. Just recording, checking that it's recording, so we got, okay. Okay, so let's go to the next page, looking at number 6. A sphere with a charge of 6, 10 to the negative 6 located. Okay. Okay. So here is the 6. Okay. Okay. Okay, so this is the negative 3. And the distance here is 4 centimeters. Okay, 0.04 meters. Let me just change that now. This way we don't make a mistake later. 0.04 meters. Okay. And then there is another charge that's down here. And this distance here is 3 centimeters. Okay. Determine the net force on the 6. Okay, so this charge here is 1.5 positive. And this is positive. Okay. So let's see what's happening here. So this 6 here will be attracted towards the negative 3. So I guess I'll call it F3. And it will be repelled by this F1.5. So I guess I'll call it F1, I guess. Okay? Yeah. Okay. That's what I did here. Okay. So now to find the force, to find F1, you just do 9, 10 to the 9 times 1.5, 10 to the negative 6 times 6, 10 to the negative 6 over 0.03 square equals I'm getting 90 newtons. The other force, which is F3, is 9, 10 to the 9th times 6, 10 to the negative 6 times 3, 10 to the negative 6 over the distance is 0.04 square, and that should give us 101.25. Okay. Now to find the net force, what we can do here is we can do. I don't want to do the chart method here because it's a right triangle. So I can take this F1, gonna make a triangle and do head to tail. So F1 is technically here. So here is the net. So the net force can be found by using Pythagorean theorem because you know those forces. So it would be 90 square plus 101.25 square, and you take the square root of that. So which gives us 135.47 newtons, right? And we're going to label this angle here as theta, okay? And we can find that by doing maybe an inverse tangent of F1 to F3. So it's 90 over 101.25. Make sure you're in degree mode, and you should get about 42 degrees. Okay, so now we have to say F net equals 135.47 at 42 degrees above the positive x-axis. Okay, because we're going to the right, in other words. Okay, let's do number 7. Okay. Not much room there. So I'll do number 7 down here. So for number 7, I have 3 charges. I have A here, yep, which is a negative charge. I have B right below it, which is a negative charge also. And I have C here-ish, which is a positive charge. And I have the values. A is negative 2.5 millicoulombs. B, or the QB is negative 3.4 milli, and QC is 2.2, positive 2.2 milli. Okay, from B to A, the distance is 6 meters. From B to C, that's 2 meters. Okay, and the question is asking find the net force on sphere A. So we're going to concentrate on A. Okay. Now I'm going to complete this triangle, and it's a right triangle. Okay. How do you know that? Well, I'm telling you. Okay. So I think we can figure out that this distance here is just radical 40, right? All right. So the force is acting on A. B is repelling it. So I guess I can call that FB. Okay. And C is attracting it. So I can call that FC. Now we can do this two ways. We can do a chart method, but first we have to find FB and FC, regardless of which method we're going to use. FB is 9 10 to the 9 times charge of A times the charge of B over the distance from A to B squared. Then we're going to do FC, which is 9 times 10 to the 9. The charge of A, which is 2.5, 10 to the negative 3. The charge of C, which is 2.2, 10 to the negative 3, over the distance that separates A and C square. So I think if I do square root of 40 squared, I get 40. So FB is 2125 newtons. FC is 1237 and a half newtons, right? Okay. So now let's start with the chart idea. Okay, so here's X, here's FB, here's FC, here's Fnet. So FB has no component in the X direction. And its Y component is positive. FC has a positive X component, right? And a negative Y component. So positive and negative. Let's start with that. Which means the Fnet here will be positive in the X direction, and we'll have to figure out the Y direction. All right, so let's try this. So I'm going to make the triangle for FC here. Okay, so this is the Y component of FC, and this is the X component. All right, so the X component. Okay, so the X component will be FC. FC will be 1237.5 times the sine of this angle here. I don't have to find that angle technically. The sine of that angle is just 2 over radical 40, right? Because this small triangle here and the large triangle are similar triangles, okay? In the answer key that I gave you in the packet, I think I found the angle, but there was no need for that. Okay, the Y component will be 1237 and a half. And this is the Y component. So it's going to be FC cosine of this angle. Well, the cosine of that angle, it should be just 6 over radical 40. And you have to do the calculations here. You have to find out how much it is. So now when you do the F net, you're going to get 391.23 here. And you're going to get 950.97 here. Okay, and you would just do, so I think you can make a, this is positive, you can make your triangle. So it should be, the x component is 391.23, the y component is pointing up. Okay, maybe I should do this. This is 391.23. This piece here is I didn't find FB. FB is just 2125. So this is 2125. You need to figure out this force here and this angle. Okay, so it should end up being 1028.30, and the angle should be about 68 degrees. All right, so let's try this with the law of cosines. See what we get. Okay. So I think if you're going to do law of cosines, let me just make sure we do it the same way I did it in the packet here. All right, the way I did it in the packet, I just put FC here, okay, and I came to here, and I put FB. Yeah, that's what I did. And then we have to figure out what this angle is, what this net force is. Okay, this is the old stuff. Now, the angle between FC and FB should be this angle here. So here we don't have a choice. We have to figure out what that angle is. Do we? I don't think we have to, actually. We can do without finding it. Yeah, we can do without it. So if this is theta, this angle here is the same. Yeah. So this is the angle theta here, which is the same as here. Yeah, so we don't have to actually find it. Maybe we'll have to do it, find it later. Okay, so let's try without it first. So the net is FB square plus FC square minus 2FB FC cosine of that angle. Well, if I take the square root of this, I'll get F net. So now the cosine of this angle here should be just 6 over radical 40. So this is 6 over radical 40, this part. So if you do the math here, and you already have everything, your F net should be 1028.30 newtons. Now we have to figure out the angle. We have to figure out this angle here. I guess we'll call it theta, we'll call this alpha. Okay, this is a different theta. Actually, I'll call this a question mark. This is my old theta. Now, we can figure out what this angle is here, because we're probably going to need it at this point. That angle can be found inside this big triangle, and it's 18.43 degrees. Okay? So now I think we need to do law of sines. So I'm going to say sine. You know what? I'm going to call this whole thing alpha. Yeah. Okay? Yeah, I'll do that. And I'm going to call this that question mark. So sine of alpha over FB, which is 2125, equals sine of 18.43 over 1028.30. Okay. So now if we do the math here, we're going to find alpha to be 40.79 degrees. Okay. But that angle is not going to make sense, because the triangle inequalities will not work. So go back to the forces problems and you'll see what I'm talking about. Or it could be the supplement of this, or 139.21 degrees. And this is the one that's going to work. Okay? Which means this question mark here. Okay? Now, we can figure out what this angle is. Okay? That's the complement of 18.43 inside this triangle. Okay? And if this is 139.21, and if this is the complement of 18.43, this is the difference. This question mark is the difference. So that angle should be about 67.64, exactly what we found earlier. All right, we're going to look at this ranking task here. So the way I like to do these problems here is that I'm going to set a standard. So I'm going to say when there is a charge Q and another charge Q, when they are separated by distance, in this case x, I'm going to say the force between them is 1F. And then I'm going to compare everything based on that. So now the distance is 1x, right? This charge is twice as much. This is 4 times as much. So I think I can say that the force between them is 8F based on what I set up here. In here, it's going to be 2 times 2. Okay? And then we'll decide whether it's attractive or repulsive. 2 times 2 divided by 1/4. That's 1/2 squared. So that's also going to be, that's going to be 16 actually. That's going to be 16F. So here we got 16F. In here is 3 times 3, and the distance hasn't changed, so the force here would be 9F. Now let's look at which ones are attractive. The attractive ones are A, B, C, and D. So C and D come first because that force is bigger, right? And it's attractive. And they're equal because of Newton's third law. The force on C is the same as the force on D. Then A and B come next because that's also attractive. Charges are opposite. This is a repulsive force. And these two forces are equal. All right, number 8. 2 tiny beads are 25 centimeters apart. Okay. Now, according to Newton's third law, the force on each one of them will be the same. So the answer should be C. Okay. For number 9, the answer should be C and D. Yeah. They have equal mass. Okay. So which means they're going to have the same acceleration. Okay. And the force between them is the same, but it's not talking about the force. So they're going to have the same acceleration because they have the same force and the same mass. So F equals ma, they have to have the same acceleration in magnitude, just going to be in opposite directions. The speed keeps increasing. Now, as they go in further apart, the force is less, which means the acceleration is less, but there's still an acceleration. They're still speeding up. It's just at a lower rate. I hope you understand that. So when they're closer together, they're speeding up faster than when they are further apart. But they're still speeding up. I mean, the rate at which they pick up speed is less. Now we're looking at the force at the center here. Well, these two forces, C and D, have to cancel, right? Because C is the force from this bottom one on this middle one, and D is the force from this top one on the middle one, because it's a repulsive force. So these two will cancel, right? So, and B is a repulsive force on the center, so the answer should be B. Let's look at number 11. So we're going to see the force on this one here. So the 2Q pushes it this way. This 2Q pushes it this way. Equal magnitude. This negative Q attracts it this way. Right? But the combination of these two is bigger than this force here. And the reason for that, because both of these charges have a bigger charge than this, and they are closer to this corner than this one here. This one is, the distance between here and here is the whole diagonal of the square. So the answer should be A. All right, let's look at 12. All right, so here we're going to just solve this equation. 2 equals 9 times 10 to the 9, okay, times q squared, not 2q, okay? They're equally charged, so it's q times q. And they're separated by 2.5 meters squared. So now if that was centimeters, you have to change it to meters. And if you do the math, you get 37 microcoulomb. Basically, you're going to get 37 times 10 to the negative 6. For 13, all right, so you're basically saying that you have a proton here, you have an electron here, okay? This is the ground below. So how far from here to here we should place the proton so that the electron is at rest? Well, if it's at rest, it means the forces acting on it are balanced. So this is the electric force and this is the gravitational force. Those two have to be equal. So we just have to say, well, mg is equal to the electrostatic force. Okay. Now the q, that's the charge of an electron. So it's 1.6 times 10 to the negative 19. Well, a proton has the same charge, just opposite. This k is 9 times 10 to the 9th. They're giving you the mass of an electron. Mass of an electron is right here, 9.1, 10 to the negative 31, times g, which is 10. And when you do the math, you should get E. Okay. All right, this is similar to the one we did. Actually, this is the one I did before. Yep, this is done. I did that earlier. Let's look at last two. All right. Again, I'm going to set a standard here. Maybe this is going to be different than what I gave you in the answer key, but I'm going to say if there is a charge Q and a charge uppercase Q, if they are separated by one box, okay, I'm going to say the force between them is 1F. So based on that, this is going to be 4 times the force, but since they are separated with 2 boxes, it's going to be 4 divided by 2 squared, so the force here would be 1F. In B, okay, so we're looking for the force on this guy here. So this is going to be, let's just assume that it's positive. And you can do the same thing and assume that it's negative. You'll get the same answers. This one on the right pushes it away. This one on the left also pushes it away. But the distance between this Q and either one of these charges is the same. And these two charges are the same, so this is going to be just 0F. Right? In other words, there will be no net force on it. In here, if I make this positive, it's going to be repelled. And it's going to also be attracted. Okay? So now let's look, and you have to add those. So the force from this negative 2Q is going to be 2 times 1, because this is 2 times as mass as charge. This hasn't changed. Divided by 2 boxes squared. So that's going to be 1/2 F. So each one of those charges will contribute with 1/2 F. So basically, the force will be 1F. In here, if this is 1, 1, 1, so we can go this 1, this is 2. This is going to be basically radical 3. So the force will be 4 times 1 divided by radical 3 squared. So this is going to be 4/3. No, this is 5, not 3. 5. So it's going to be 4/5 of F. In here, it's going to be 8 times 1 divided by, now let's see how much that is. This is 2, this is 2, so which means this distance here is radical 8, so it's going to be 8 times 1 divided by radical 8 squared. So the force here will be 1F. Now, so the order is going to be, A, C, and E together, first place. And the next one will be D, and then B is last. This is ACE. All right, last one. Okay, so I'm going to call this L here. So I'm going to use the same idea. Here's my standard. Two charges Q and Q separated by distance L. The force between them is 1F. So we're looking at what's happening to this one down here. So it's going to be repelled and repelled. Okay. This force here is going to be 4F. This force here is just going to be 2F. We'll come back to that later. In here, it's going to be repelled and repelled. So this force here will be 2F, and this force here will be also 2F. This is going to repel it. This is going to attract it. 2F and 2F. Okay. This is it's gonna repel, and it's gonna repel. Right? This is gonna be 4F and 4F. So let's see which one is gonna give us a bigger combination. So if I take, so if I take 4F and I put it here, I get this as the net force. For 2F here, I get this as the net force. And here, if I put this here, I get a smaller force. Then this 2 okay. So it looks like the biggest one will be D, then comes A, then comes B, and C will be in last place. Okay, just based on those drawings, and that should do it.